Anyway, thank you very much, Rodrigo-san. Good morning, Chileans, and good evening, Japanese. I'm Satoshi Ide from Kubota Corporation. It's my pleasure to make a presentation in this first Japan-Chile Symposium. Today, I would like to introduce Kubota's challenge to smart agriculture. Yesterday, Professor Noguchi introduced cutting-edge research on next-generation agricultural robotics. Today, I'd like to tell you what is happening in the real field of agriculture in Japan. Okay, sorry.
Sorry, maybe you can try to start again the presentation.
Okay, now it's okay. This shows today's topics. Kubota at a glance, challenge in Japanese agriculture, and Kubota smart agriculture, future direction. First of all, let me introduce an overview of Kubota. Kubota was established in 1890, and we celebrated its 130th years anniversary last year. Now, over 41,000 employees are working all over the world. We produce a wide range of products from farm machinery to engines, compact construction machinery, and water and environment-related products. All our products are related to food, water, and environment, which link to SDGs. Next, take a look at the sales by business segment. The total sales in 2020 reached about 18 billion US dollars. As you can see, 2/3 of our business come from farm machinery business, including agricultural machinery and engine business. We are now competing second place with CNH in the agricultural machinery segment. And we hold the largest market share in the industrial diesel engines with 100 horsepower less. We have a global sales network covering over 110 countries, and we have 14 overseas production sites in North America, Europe, and Asia. As for regional sales, Japan is only 32%, North America is 35%, already larger than Japan. Europe is at 12%, and Asia is 70%. Of course, we also have a sales network in Chile. A distributor called Southmax sells our product and covers central Chile with 17 outlets. They have a market share of about 15% on tractor in Chile. If you have a chance, why not drop in the head office in San Bernardo? Kubota aims to be a global major brand which is trusted by the maximum number of customers around the world. Not just supplying product, we provide solution and new value to our customer through innovations, utilizing new technologies such as ICT, IoT, and AI, etc. Now I'll explain the challenge that Japanese agriculture faces. The smart product, the farming population is significantly decreasing due to aging and retirement. The left graph shows the number of farmers decreased by more than half in the last 20 years, and their average age reached 68 years old. On the other hand, the number of large professional farmers who wanted to expand their farmland is increasing, as you can see right figures. The government of Japan has also taken several measures to support such farmers to expand their farmland and to enhance their productivity. The government expects that 80% of arable land will be cultivated by professional farmers by 2023. In Japan, The average area of a farm lot is very small. It's about 0.2 to 0.3 hectare. As I said, due to small farmers' retirement and consolidation of farmland by large professional farmer has been in progress. As a result, they became to manage hundreds of farm lots. For example, the farmer who have 40-hectare farmland have to manage approximately 200 farm lots. With that kind of background, professional farmers are facing many challenges as follows. Number one, first, efficient management of such multiple farm lots to increase yield and quality of a farm product. And second, reduction of cost and raising the value of product to make agriculture profitable. And fourth, improvement of working environment and with human resource development, including transferring skill and know-how to younger generations. Kubota is tackling smart agriculture to solve these challenges and to reform Japanese agriculture as follows. First, realize profitable and sustainable agriculture. And second, solving the labor shortage and promoting younger generation to join by reducing heavy work and improving working conditions. Third, revitalizing rural area and maintain multifunctional role of agriculture. The government of Japan has also promoted smart agriculture under the policy of Society 5.0. The government defines the aim of smart agriculture as follows. To realize smart agriculture, Kubota has been developing and commercialized the following three categories of smart agricultural technologies. First, precise farming system utilizing a variety of agricultural data named Kubota Smart Agriculture System. Hereafter, I call KSAS. Second, super labor saving technologies such as automation and unmanned agricultural machinery. Third, workload reduction technologies such as assist suits, drones, and radio control mower, etc. This just shows the cultivation cycle and its mechanization system for Japanese rice farming that has been developed so far. Today, almost all work is mechanized. However, the intermediate works, such as the top dressing, spraying, water management, and weeding, are often still done manually. So we also have to reduce these hard work, which harm human health, by introducing smart agriculture. This is a typical example of Kubota Smart Agriculture System for rice and upland crop farming. We offer various kinds of automated farm machinery necessary for rice farming, such as automated tractors, rice transplanters, a water management system, and radio control mower, remote sensing and spraying drone, automatic harvesters with Kubota's original sensing system and drying system. And these machinery are connected to the data management system, KSAS, that is the conning tower of smart agriculture. Then I will introduce KSAS in the next. KSAS is a farming management system that realizes a profitable PDCA-based agriculture by utilizing various agricultural data on farm works, crops, field environment through connected agricultural machinery and field and remote sensing system, etc. KSAS enables the following. Number one is producing good taste rice or crops in high yield. Number two is transferring agricultural skill and know-how by communicating farm work information correctly, which prevent workers from making a mistake. Number 3 is ensuring safety of crop by recording the traceability of farm work. Number 4 is reducing total cost and raising profitability. Cases also include machinery service system, which deliver quick repairing service and proactive maintenance service. I believe cases finally realize profitable farming management. This is a schematic diagram of cases. The structure of cases is quite simple. It consists of 3 components. One is cases agricultural machinery equipped with a Wi-Fi or direct communication unit, which collect crop data and machine operation data by various sensors. Second is a cases mobile owned by workers on site, which transfers the data from case agricultural machinery and his work record. Vice versa, the working plan and the daily schedule made by farm manager is transferred to the workers via cases. Cases mobile. Third is the cases cloud, in which the various agricultural data are accumulated hierarchically on each farm lot and analyzed in order to propose adequate farming work such as fertilizing, pesticide, and water management, etc., utilizing external information such as a weather forecast. On this scheme, farm support system and machinery service systems are configured. I will explain the overview of cases step 1, which is currently fully in service. Step 1 is to realize the Japanese-style data-driven precision farming connected with agricultural machinery for rice or crop farming. Cases provide farm work management system in which farm manager creates a planting plan and working plan based on the map of each farm lot and are able to monitor the progress of farm work. And cases also provide PDCA-based agriculture connected with farm machinery as follows. This machinery. I will talk more about it next. This is a combine harvester with taste and yield sensor, which plays one of the most important role in cases system. This machine can measure the moisture and protein content of a paddy, which has a negative correlation with taste by infrared spectroscopy, and also measures the yield by a load cell under the grain tank. Here. And this data is sent to cases cloud via mobile or direct communication unit. I will explain how to realize a PDCA-based agriculture. Number 1. Based on the data from the harvester, we can grasp the description of yield and taste of each farm lot at a glance, like the left graph. You can see this graph. Y-axis shows the yield, X-axis shows the protein content, and this pink zone shows the target zone. And number 2, by sorting a high quality product within this target zone, farmer can sell it at a higher price. Number 3, then by analyzing this data, it enables to create a specialized fertilization plan of each farm lot. This fertilization plan is sent to the agricultural machinery through cases mobile or direct communication unit, and the machinery automatically controls the amount of fertilizers for each farm lot. In this way, we are able to improve the yield and quality of our product year by year by rotating a PDCA cycle. This is a result of 3 years monitoring test conducted in Niigata Prefecture in Japan. The first year, yield and protein content scatters like this left figure, and only 1/3 of a farm lot were within a target zone. After improving the amount of fertilizer every year, yield and protein contents enter this target zone. And finally, we confirmed that the total yield increased by 15% in 3 years. Now, I will show you the conceptual movie on Quesas. Thank you. I will briefly explain the current status of dissemination of Quesas in Japan. After launching Quesas in 2014, total subscribers of Quesas reached over 11,000. The number of farmers who utilize the farm management system has increased step by step and reached over 2,200 this year. Here I will explain the direction of future evolution of KSAS. As mentioned earlier, step 1 has been almost completed, and we will strengthen the development from rice and upland farming to vegetable and fruit farming. Step 2 is the next step of the Japanese precision farming, which are currently tackling. The Japanese government has reinforced the improvement of the farmland infrastructure, which includes the consolidation of small farm lots. As a consolidated large farm lot is composed by several small farm lots, so soil conditions vary from place to place. Crop growth is affected by soil conditions as well as the weather, water level, and field environment, pest and weed, etc. So in step 2, we grasp the unevenness of growth by utilizing field and remote sensing in addition to the desperation of yield and taste. And we perform more precise control of cultivation process, that is variable rate application of fertilizer and pesticide, water management, etc. Step 3 is a construction of an advanced farming support system using AI, etc. I'll explain the outline of each step next. Step 2 consists of the following 4 original technologies. Number 1 is mesh-map combine harvesters and variable application of fertilizer. Number 2 is remote sensing and variable top dressing and spraying. Number 3 is the automatic water management system with water level sensor. Number 4 is the determination of optimum timing of cultivation work by utilizing weather forecast and the plant growth model. Next, I will explain number 1 to number 3. This screen shows the mesh-map combine harvester that is a core of the KSAS step 2. This combine harvester is equipped with a new sensor system that can measure yield and protein content every several square meters based on the position information of GNSS. So it's enabled to create a mesh map of yield and taste. In addition, the direct communication unit allows these data to be sent to the KSAS cloud automatically. This general purpose combine harvester can harvest not only paddy rice, but also upland crops such as wheat and soybean. This screen shows an outline of the variable rate fertilization based on the mesh map data obtained by combine harvester. The mesh map data of yield and taste stored hierarchically on the GIS of each farm lot, together with soil analysis data, like this center one. And we call this data structure as KSAS layer map. By analyzing this data, a variable fertilization map is created by original algorithm. Based on this variable fertilization map, variable fertilization is carried out using a spreader or a drone, etc., that can adjust the amount of fertilizer for each mesh. As a result, it became possible to make each farm lot less dispersion in yield and taste. This is a result of a variable rate fertilization test. As you can see, this upper left figures, this one. First year, the yield data at the right side of the field was lower than the other part. As a result of variable fertilization in the second year, this is the second year, we could achieve both of increasing the yield by 25% and improvement of the dispersion in the yield. The lower part of this figure shows the change of the protein content. We also found that improvement of the dispersion. This one. Next, I will talk about the remote sensing by drone and variable top dressing, etc. This sheet shows a specification of a remote sensing drones and its feature. Number one, the drone equipped with a 5-band spectral camera for agriculture. Number two, it is capable to collect wide range of growth indicators such as NDVI, etc. In short time. For example, only 15 minutes for 10 hectares. And number three, the original algorithm make it easy to generate a growth map and to upload to KSAS. Number four, based on these maps, you can perform variable rate top dressing in the similar way as shown before. This figure shows an example of remote sensing. 12 hectares of field composed 40 farm lots was photographed at once in the rice ear formation period. It only takes 30 minutes to generate this NDVI map and to upload KSAS. By examining the farm lot with large color change, like this farm lot, you can see this color change one. And you can find abnormal condition and take countermeasures such as top dressing and chemical spraying. This figure shows the two examples of field damaged by pest and weed. The left photo shows a field damaged by plant hopper. It's easy to find damaged place by using NDVI image rather than RGB image. And the right figure shows a field with a heavy weed. You can also find them easily by using NDVI image. The third technology is the water management system called WATERAS. This system has been developed with NARO, that is National Agriculture and Food Research Organization. And in this system, based on the water level sensor, this one, this center, the water level of each paddy field is adjusted automatically by controlling the supplying and drainage valve. Water level data is sent to the cloud together with water temperature via LPWA and direct communication unit. It enables remote monitoring of water level by a smartphone and program control of water level. So a farmer have to look around many paddy fields and adjust the water level one by one. After launching the system since 2018, approximately 80% of a labor reduction in water management was proven on many experimental projects. Now, utilizing the weather information and growth model, optimum water management method is under development. Utilizing the WATERAS, total water management system of the farming area, are developed by the project sponsored by the government. This project aims to control whole water supply from reservoir to the field and to contribute saving water of a whole farming village. Next, I will explain KSAS step 3 using these figures. The aim of step 3 is building an advanced farm management support system which can support to make optimal business plan and cropping plan in order to maximize the profit of Arab farmers and support to make optimum work plan detailing where, when, by whom, which machinery should be operated in order to maximize efficiency. For this purpose, KSAS is connected to the agricultural data collaboration platform called WAGRI, operated by NARO, and external information systems, such as market information from distribution network. By analyzing accumulated KSAS layer map data, combining these external data, KSAS user will become able to create the optimum farm management plan for his farm. In order to make CASAS more popular, it must be easier for farmers to operate. Moreover, CASAS need to be connected to various systems and machinery from other companies. Therefore, we aim to make CASAS an open platform which connects to data collaboration platform WAGRI and various systems from other companies. For that purpose, standardization of agricultural data is indispensable, and it's being considered by the government project. Okay, now let's explain the development of automated and unmanned farm machinery. The Japanese government, Ministry of Agriculture, Forestry, and the Fisheries defines 3 levels of the automation as shown in these figures. Level 1 is automated auto steering technology for the machine with an operators. Level 2 is unmanned machinery, but unmanned monitoring. That includes the harmonized work of multiple units. I will show you later. Level 3 is completely autonomous. Level 3 is completely autonomous machinery with remote monitoring. This level also includes the multi-robot system that controls multiple units simultaneously, and also the traveling on public road. But this is the roadmap for Kubota's development of automated and unmanned farm machinery. We have been reinforcing the development of level 1 or 2 machines named AgriRobo series. As a result, the level 1 machinery becomes more and more popular in Japanese agriculture market, this one. However, as for the level 2 machinery, the advanced farmer have just started using on the many verification projects for smart agriculture. As for the level 3, it requires not only research and development, but also the creation of standard and the infrastructure in cooperation with the government. Therefore, we are now working on several governmental projects cooperating with the government, industry, and academia, under the strong leadership of Professor Noguchi. Hereafter, I introduce some level 1 and level 2 machines, not level 3. Level 3 is already presented from Professor Noguchi-san yesterday. First, please take a look at the movie of the auto steering of the larger plant farming tractors M7 series. This machine is equipped with RTK GNSS, similar to other companies, but superior performance is realized by developing original control algorithms. The next is a rice transplanter with a straight traveling function. Launched in 2016, we developed Kubota's original control system by combining a DGPS unit and inertia measurement unit, IMU. We were able to offer the straight traveling function at much less expensive price than conventional RTK GNSS system. Of course, this system is not as accurate as RTK GNSS, but the performance is found to be sufficient for professional farmers. In addition, we are able to add the following new value to the customers. Number 1, the making straight traveling easier, even for the beginners and the part-time workers. Number 2, revealing operators' stress. Number 3, improving efficiency by allowing the operator to check seedlings and fertilizer quantity while planting. For this reason, this feature was well accepted from professional farmers and it becomes popular for the professional models. Now, I'll show you the movie of the first transplanter models with straight traveling function. Next is a small and medium-sized tractor with straight traveling function launched in 2019. The concept of this system is almost the same as the rice transplanter. These tractor models are also becoming more popular in Japan. These are the combine harvester with automatic driving assistance function, which appears in the TV drama in Japan. Based on the position information by RTK GNSS, the optimum leaping route are derived so as to minimize the working hours. And all the operations such as driving, swiveling, and lifting the leapers are automatically controlled. In addition, estimating the position where the grain tank is full, the machine moves to the grain containers for unloading. Then go back to the optimum restarting position by calculating an optimum route. This automatic driving assistance function enabled operators with less experience, like a younger generation, to perform efficient harvesting and to reduce their workload. Now, this is the first level 2 unmanned tractor named AgriRobo SL68. Which we started test marketing in 2017. The high precision RTK GNSS unit, which we manufactured in-house, made it possible to perform automatic driving with a single unmanned machine. And the second, cooperative driving with a pair of manned and unmanned machinery working together, and reducing operator stress by means of the automatic steering function. I'll explain how to define the outline of the field. In this way, the shape of the cultivated field is measured and memorized by driving tractor around the outer circumference of the field. You can even define the non-rectangular field in the same way. Once the field shape is memorized, it can be reused at any time you like. And the inner parts, only inner parts, except these outer circumference, are cultivated automatically. As for the safety, it has a variety of safety functions supported by 4 surround view camera and 3 laser scanner and 8 ultrasonic sonar, which meets the Japanese safety guideline established for the unmanned tractors. If obstacles are detected within this range, the tractor stops automatically or doesn't start moving. Now I'll show you the movie of the AgriRobo tractor SL68. This is a cooperative one of 2 machines, manned machines, and this is a manned machine.
直進はもちろん旋回もそして枕地降雲も可能。自動運転作業は降雲と白かき作業が可能。 数々のセンサで障害物を感知、自動的に停止する安全機能。アグリロボトラクタはオートステアリング機能を搭載しているので、直進キープ作業としても使用できます。
And several demonstration tests have shown that this cooperated operation increases the efficiency of the tillage work by around 1.5 times more. This screen shows the first level 2 ammound rice transplanter released this spring. Now, after defining the outline in cells in the same way as tractors, ammound autonomous operation is executed, except for the outer circumference. Coordinated operation by manned and unmanned machinery increase the efficiency of transplanting by about 1.5 times, 1.8 times, as shown this figure. Of course, it has a safety function supported by 8 sonars, which meets the safety guideline of the Japanese government. Now you
大
can
規模
see
水田作
the
一貫
movie.
体系をロボット化するトラクター、田植え機、コンバインの3機種を参考出品として初公開いたします。アグリロボトラクタは大区画補助に対応する100馬力。オペレーター監視のもと、耕運、白かき、施肥などの作業を無人で行います。またレーザースキャナー、超音波ソナーなどの安全装置や周囲監視用のカメラも装備しています。さらにお手持ちのトラクターと無人アグリロボトラクターによる2台同時作業も可能です。アグリロボ田植え機はオペレーターが搭乗する8畳上、補助形状をもとに無駄のない作業ルートを自動計算、 RTK-GPS による安定した植え付け作業に加え、180度ターンや植え付けクラッチの入り切りも自動。不慣れな方でも高精度な作業が可能です。またオペレーター監視下での無人運転にも挑戦しています。アグリロボコンバインは自脱型6畳刈り。オペレーターが登場して自動で刈り取り作業を行います。グレンタンクのもみ貯留量とコンバインの位置情報をもとに最適な作業ルートでの刈り取りともみ排出ポイントへの離脱を自動で行います。オペレーターは刈り取り状況や安全確認に集中でき、作業の効率化と大幅な経路化を両立しました。久保田が目指す大規模水田作のスマート農業一貫体系。
These are all commercialized. Now I will explain the several challenges to popularize the level 2 machineries. Number one, refining the safety functions by utilizing AI image processing in order to prevent from misdetection. Number two, increasing the ratio of autonomous operation in one field. The ultimate goal is to be fully autonomous. Number three, broadening the range of autonomous work by applying to various implements. Number four, improving the infrastructure such as RTK, GNS base station, and farmland consolidation for autonomous operation, etc. This is a role of the government or municipality. Regarding the challenge of the level 3, this part is almost same as Professor Noguchi-san said yesterday. But just I emphasize second one, and the high-speed communication network, including 5G, is necessary. So rest I will skip this. Next, I will explain some technologies for labor saving and workload reduction, which are already on sale. Number one is a spraying drone, which becomes very popular in Japan. And second is a radio-controlled mower, which enables us as stable mooring even on the 40 degrees field reach. Number 3 shows assist suit rack vest used in orchard and vineyard. Number 4 is a winch type power assist suits for lifting heavy harvest container, etc. Sorry, I don't have enough time to explain more. The government has set a goal for almost all professional farmers to use the data by 2025. Then I introduced the initiative of Japanese government to promote smart agriculture. And number 1 is supporting the development and introducing by Agritech Ventures. Number 2 is enhancing the training and education in the agricultural high school and college. Number 3 is strongly promoting implementation of a demonstration project for smart agriculture. Since 2019, 148 projects have been put into practice, and Kubota joined many projects. Number 4 is development of infrastructure in the rural area to be suitable for smart agriculture. Number 5 is constructing agricultural data collaboration platform named WAGRI, as I explained. And here I will introduce Kubota's effort for dissemination of smart agriculture. Regarding R&D, we have endeavored to expand our product line. At the same time, we are working to improve our product and reduce costs by reflecting the true voice of our customers. I believe that these smart products should be super user-friendly. For dissemination, this one, we hold cases and AgriRob trial campaign and regional workshop directly to the farmers at all parts of Japan. Unfortunately, we have been holding webinars since last year. I would like to summarize the value of the Kubota wanted to deliver to the customers through smart agriculture systems. And the number 1 is realize profitable agriculture by improving productivity, increasing the yield and taste, reducing cost and expanding farm scale without increasing farm workforce. This is very important. Number 2 is reducing heavy work and dangerous work, which brings work style reformation. And number 3 is reducing the environmental load and promoting organic farm, etc. Okay, now I talk about the future direction of Kubota Smart Agriculture. So far, we reinforced to develop the smart agriculture system not only for rice or crop farming, but also for vegetable and orchard farming, etc. We also intend to contribute to not only large professional farmers, but also leading farmers in hill area. Finally, we would like to develop overseas markets. And the second, we aim constructing advanced farm management system linked to smart food value chain in order to produce crops required in the market, in required quantity, and in adequate timing by utilizing market data by WAGRI, etc. This results in the minimize the food loss. And Kubota has established the Innovation Center in Japan and Europe in 2019 in order to create new business by open innovation. Its main activity is investing in startups, creating new business and participation by R&D project together with academia and the government. To promote smart agriculture abroad, that we have already invested in several overseas agritech ventures. This is a final slide. I introduced the concept model of the future fully automated tractor exhibited in January last year. Okay, finally, I hope that cooperative relationship between Chile and Japan will be further developed. Thank you very much for your attention.